So, hello and welcome everybody to our today's event, a special event. And yeah, hello from our side, from Fronius, from my side. My name is Christoph. And I also want to put a very warm welcome out there to our joint partner for today's event from ELUM. And today with me is Christian. I jump right to the next slide where you can see him also here. So Christian Carsten, he's from ELUM. Thank you. Thank you very much for being here with us today for this special training around PV-Genset solutions with Fronius and ELUM in a joint progress. So we have prepared a joint webinar for you. It's consisting of two parts, obviously. So we will have a Fronius part on the inverter side. We will talk about how a PV-Genset is built up, what components are inside there, and what role does the PV plays in it. That will be the first part, more or less, for this presentation today. And the second part, then I will hand over to Christian, and he will basically talk about the ELUM side. So what components are available from their side? How can they contribute in this scenario? What is a PV plant controller or a PV-Genset controller doing actually? So these questions will be then answered by Christian. So thank you guys again for being with us. We want to have this as interactive as possible. So there is my first question to you out there joining this webinar. If you have any questions around this topic on Fronius or ELUM side, don't hesitate and use the chat function. You have the possibility to chat with us on the right-hand side of your screen. There are multiple people as organizer logged into this event who have access to this chat and can answer you directly from Fronius and ELUM side. And at the end, if possible, we will also take a few minutes time to answer a few of your questions live then. So please make use of that. It would be great, again, also to have you as interactive, integrated in this session as possible. Okay, so without further ado, let's get started and let's check out the agenda for today. So Fronius PV-Genset solutions, obviously that's the topic. And yeah, we start with the Fronius part, as I've mentioned. And the first question I want to answer is, how is a PV-Genset system actually defined by Fronius? What has to be integrated in such a system that we can call it a PV-Genset solution? On the one hand side, of course, there is a diesel generator or multiple ones in it. In some scenarios, these diesel generators are building up the grid permanently, so they are responsible for 100% of the grid security because there is no other grid. Then we have the loads, of course, we have a controlling mechanism, and then we also have a PV system on the roof or a free field installation contributing into the system. So that's the diesel generator doesn't have to put up so much power. So we relieve the diesel generator of some percentage of its power. We save fuel, we save electricity, and of course, that's the goal at the end of the day. So those components are in such a system, and then we can call it PV-Genset solution. The second question would be, who is interested in such a system? Where does it occur? Who is working with such a solution? Of course, the answer to all of these solutions is a place, very rural sometimes, where there is a weak or even no grid. And some customer segments could be a factory, production site, for example, tourism. Of course, there can be remote located hotels or resorts, for example, and they are, of course, in need of high power demand. Then they sometimes use a PV-Genset solution. Mining would be another solution or a segment of customer, and food processing or in general agricultural solutions. And in every scenario, you can differentiate between different sizes of PV systems dependent on the size of the diesel generator. And dependent on that ratio, we talk about a low penetration PV-Genset system or a high penetration system. So the difference between those two is that the low penetration system, like we can see here on the screen again, is that compared to the load and compared to the diesel generator, the PV plays a very small role. It's very small in size, low penetrating. And what we can see in this schematic, for example, would be a load curve. So if you follow the outline of this gray, multiple color gray curve here, this would be the load curve, and the dark gray area, this would be the amount of energy covered by the PV system. And if you compare it, for example, to the rest of the gray area, this is not the big amount. So low penetration system means very small PV system in a PV-Genset solution. So in an ideal solution with a low penetration PV-Genset solution, you are not in need of doing any kind of controlling, because you are never in that scenario where you would have to shut down the PV because it's too much energy. Not happening in a low penetrating system. The other scenario would be quite the opposite, a high penetration PV-Genset solution and the need of a control. So we have again the same load profile, but now we have a bigger production, a bigger PV system. So the red curve would be the PV curve. And again, we can see the dark gray area, which is covered by the PV. And you can see around mid of so noon and afternoon, we can see here there is a straight line. And this is where the control sets in and cuts down the output power of the inverters in order for the PV-Genset solution, or the generator in this case, to not go below a certain RPM level. Because of course, such a diesel generator has its optimum efficiency rate, and this is dependent on a RPM, and this should not be undershoot. And in order to do that, we have then a controlling mechanism. For example, with ELUM, this is possible to do that. So we regulate down the PV system so that the generator is always working on its best efficiency level. So this would be a high penetrating PV-Genset solution. Again, we have here the big exclamation mark on the right-hand side telling us, okay, we need in any case of a high penetrating system, a dynamic control of the whole system. Okay, and today especially, we are going to talk about what is called a Fronius PV-Genset advanced solution. Because in an advanced solution, we have the need of a dynamic control. We have something third party monitoring the whole thing and controlling the whole thing. In our scenario, this is ELUM, and we have those components in such a system. We can see here the generator system. Multiple ones can of course be included in such a scenario. We have the loads. There can be even batteries included, depending on the product that you use, also from ELUM side. Then we have a solar controller, also a ELUM component in this scenario. There can be a grid connection, but there doesn't have to be one. And of course, from Fronius side, we have our inverters stacked up and contributing to this system. And this is how it works. The solar controller is measuring, of course, the load profile of the system. And dependent on what's needed, he's checking the generator, okay, on what level, on what efficiency level are we working on? What is coming from the solar system? And do we have to shut down the PV or not? And this is basically how it works. I mean, there is, of course, more technical detail behind this. We will come to that in a later slide, but the basic the basic working around these components is like that. Okay, again, to sum up what I've mentioned in the previous slide, the main task then for the PV-Genset controller is that the diesel generator, of course, is more or less the core component. We have to protect this from overloads and from running in a bad efficiency level. And the main task for the controller is to protect the diesel generator. And in order to do that, we sometimes have to regulate or to shut down the PV in order to do that. I think I have a few animations in here. Okay, we see it here. So we have something called a minimum genset load. This is the gray bar at the bottom. We don't want to go below that and there is always a certain amount of power coming from the diesel generator because of that, the bad efficiency that comes from it otherwise. Then we have the inverter power, and we also have the maximum PV power, and we can see here we would have more energy from PV, but because there is probably no grid, we can't go anywhere with this energy, so we have to shut it down because of the minimum genset load. This is the main task of the PV genset controller. All right, so this answers probably already a few of the questions listed here. Why should we use a PV genset solution anyway? Stability of the entire PV genset system. Of course, as you can imagine, with the stability of the PV production, we are not dependent on big load jumps or something like that. We can contribute in a stability of the system again with the PV solution. It is an easy integration to an existing genset. It's quite easy to do so. We just need a few components, which we will hear from later on by Christian. And another point would be to save money. Of course, as you can imagine, if the genset doesn't have to run full throttle whole day long, we save a lot of fuel. Fuel is expensive, went on a very rapid price increase in the last few months and years, and probably will continue to do so. And also we lower the energy prices, of course. I have also a quick calculation for you in a later slide to compare it a little bit. We have a rapid amortization, and therefore it's also a real business case. Again, I'm linking to the calculation that I have prepared for you in the next few slides. We are also decoupling from fossil fuels, so we are not that dependent on such a thing. So if there is any shortage, delivery for the diesel is running late, it's not that big of a deal anymore, or not in such extent if we have a PV system contributing to the system. And last but not least, if we think about climate change and all that comes with it, we want to reduce the carbon footprint, of course. Also a major task we need to focus with such a solution. Okay, yeah, we have mentioned that already. Then I have prepared for you a reference system. And after this reference system, or based on this reference system, I have done a quick calculation, or more or less a colleague, an expert from the product management team, did a good calculation on that, and we can see what's the return on investment time on such a system. So what we can see here is a irrigation system located in Lebanon. We have around 144 kilowatt peak with a generator size of 280 kilovolt amps. And yeah, as I mentioned, because of this irrigation system, you can imagine there is a lot a big energy demand, and we cover a small percentage of that by using our PV Genset solution. So in total, we have implemented 6 Fronius snap inverter with the size of 20 kV each. And also here we are talking about the Fronius PV system controller. This is not on the market anymore, but this was a PV Genset easy solution, we have called it previously, which was a very simple and small controller for a single Genset solution. If there would be more, if it's a bigger installation and has more complexity to it, then we talk about an advanced solution, and then again we are in need of third-party units by ELUM, for example. So in total, we're talking about 216,000 kilowatt hours of annual yield by this PV system, and a lot of CO2 equivalent that we save per year. So in total, we talk about 40% of self-efficiency, because of this PV system. And it was commissioned quite a while ago in December of 2014. And since then, it's running fine. And now I'm coming to this calculation I've mentioned earlier. So based on this system and on those numbers we have seen before, we have done a calculation. We can remember we were talking about 144 kilowatt peak, about a yield of 200,000 kilowatt hours per year. And based on real life numbers from now, we can calculate with around about 15 euro cents per kilowatt hour that we need for the PV power. On the other hand side, we have the diesel generator, and per kilowatt hour that we get out of the diesel generator, we calculate with 50 cents, something like this. And with those numbers, we come to the conclusion, okay, I have to also mention this below. The total cost for the PV plant with this 144 kilowatt peak is around 260,000 euros. And if we take the numbers above into account and do a calculation, the return on investment would be reached in 4.8 years. So after the 5th year, we are making benefit. It's just beneficial after the 5th year. So it really doesn't take us that long in years. So it happened already for this system, as we can calculate from it, because it was commissioned in 2014 to 15. And from the 5th year, it's gonna produce around about 68,000 euros plus for this owner of the system. He's saving a lot of money and energy because of this. So highly recommendable. It is profitable and boosting your return on investment, definitely. Okay, last but not least, I quickly want to talk about a few design rules and how you can get started easily and fast with this. First of all, I want to mention there is a PV-Genset checklist on our homepage available. You can just search for it on the download section and fill it out and send it through. We will be happy to guide you and assist you there as well. So we are doing a planning and a support here with the tool called HOMA simulation. But again, we have ELUM here with us today in this webinar. I also want to link to their homepage, to their contacts. If you have any question, you can of course contact ELUM directly as well. And yeah, now to the design rules. There are some regulations or some recommendations we would highly recommend to do. First of all, please check out the minimum genset load. Every system has a limit, of course. In 95% of the cases, this limit is on around about 30%. So we never should go below 30% of this genset load. Otherwise, we have a bad efficiency. There are some out there which go down to 25 or 20%, but better be on the safe side. So I would say never go below 30% of genset loading. The second topic would be the maximum AC inverter power should not exceed 60 to 70%. Again, you can see the link to the 30% of the genset. That's the reason why we don't want to cover too much of the load that we have in order for the genset to always run at a minimum genset loading. And the third part listed in this screen is we should have you should have an in-depth load profile analysis available. So what's the maximum power occurring? What's the average? The daytime load? Is there seasonal changes, for example? So this has to be known by you in order to do a good planning of the system. A few more things. When it comes to the DC side, to the inverter side of the inverter of the system, you can think about oversizing it. If you have worked with Fronius before, you probably know that, but there is something called over-dimensioning ratio, which is possible to do with our inverters. We can over-dimension it on the DC side by 150%. So an example, if we have a 10 kilowatt inverter, we can do a 15 kilowatt peak system on this inverter without harming the warranty. I can highly recommend to do that. maybe not to 150%, but to 140%, easy without any problems, because we never have the perfect irradiation levels. Either it's too hot or it's cloudy or anything can happen. And typically on a whole year schedule, we don't have the perfect conditions for such a scenario. So it's possible to do that over sizing in order to get the maximum out of the system. And as well, if you're thinking about the east-west installation, also highly recommendable in order to maximize this DC to AC ratio and to do the oversizing. Okay, and last but not least, the topic we have already explained, we require the involvement of a plant controller, ELUM in this case, in a PV-Genset advanced solution. So when we talk about a multiple genset solution, which we do in this webinar. So one last thing, of course, there are power ranges. For example, there is also something called a PV-Genset advanced solution. We have heard this now. And there is also something called a PV-Genset professional solution. And the difference basically is also the size and the complexity. So in both cases, we talk about multiple genset solutions and sizes of 100 to 2 megawatt of genset power. And in a professional solution, we start at 200 kilowatt and go up to 5 megawatt of genset power. And the difference is basically that in a professional solution, we have everything from one brand. So the controller and the PV-Genset controller, so there can be multiple controlling units in such a system. They all are from the same brand and working together on a same eye level of communication. And then we talk about the professional solution. Okay, and last but not least, I want to show you a little bit of an overview of which inverter can be used for such a system before I hand over to Christian and the part for ELUM. And yeah, maybe you have heard of this. We have something called the Fronius Taro inverter. It's a big inverter for commercial units. We have it in 50 or 100 kilowatt of inverter power AC. And therefore, it's perfectly usable for such a system like PV-Genset solutions, and therefore also a big PV generator on top of the roof also. We have a so-called Fronius Taro Eco solution and a Fronius Taro solution. The Fronius Taro Eco has only one MPP tracker, but is available in 50 or 100 kilowatt. And the Fronius Taro, or also called Fronius Taro Standard, is available with 3 MPP trackers, but only 50 kilowatt. So depending on the complexity of your roof, you can choose between those two systems, or you can also combine it, of course, in such a system, in one system. And there are even more variants out there. Don't want to go into too much detail. We have a special online training and webinar for that product. But there is something called a direct version of this Taro and a pre-combined version. And this is dependent on where the inverter is located in your system. Is it near the inverter? Is it near the PV module right next to it, for example, on the roof? You can directly connect the strings via MC4 plugs to the inverter via MC4 connectors. And here we talk about the direct solution. So it has pre-configured MC4 plugs at the bottom. If the position of the inverter is a little further away from the modules, from the arrays, and you would have to cross a bigger distance on the DC side, you can choose the pre-combined options because it has not pre-combined MC4 connectors on it, but it has big V-clamps, very big V-clamps, where you can connect up to 95 square millimeters of DC cable to it. So you can pre-connect all of the modules on the roof, on big combiner boxes, for example, and then you run down big DC cables to the inverter. So 2 options for 2 scenarios. But that's not the only product which can be used for a PV-Genset solution. There is also something called a Fronius step inverter. So it's on the market a little bit longer, but it's very trustworthy. It's running for years now, and we have there as well big solutions. For example, the big SIMO inverter on the left-hand side, covering the ranges from 10 to 20 kilowatt. Or on the right-hand side, we can see the Fronius Echo snap inverter, which is basically the SIMO inverter with a few components put out. It is then a little bit limited, so we have not such a big DC operating range, but it's perfectly fine if we have a big system on the roof. This shouldn't worry us. We have it in power classes 25 and 27 kilowatt, and it has one MPP tracker compared to the SIMO inverter on the left-hand side with 2. So again, we can do a mixture of those two, or we can even include the Taro with those snap inverters in such a system. Doesn't matter how you want to do it, you can do it with the Fronius product line. All right, the communication looks the following. We have on the Taro something called the pilot card inserted into it, which is more or less the communication center of the inverter. And every inverter has one of those cards inserted. And from this pilot card, from this communication center, we can then connect to the ELUM components either via Modbus RTU, via an Ethernet cable and the use of Modbus TCP, or we can also use the protocol Solar API in order to communicate with ELUM on giving them the information they need, of course, for the regulating of the whole system. And what's also very cool about it is that we can use the communication to ELUM, and in parallel also we can connect Fronius SolarWeb to it. So our online visualization platform is available as well, and we have the possibility to view it, or the customer can view it via SolarWeb, and it can be controlled via ELUM via the following communication connections. So that's possible. And the same thing also goes for the snap inverters. We also have something called the data manager card inserted there. And from there we have Modbus RTU, Modbus TCP, and the Solar API in the JSON protocol we can use for the transfer of the data. And also on the left-hand bottom corner, we can see something called Solar Net Ring to other snap inverters. This is valid for the snap inverters. We can connect multiple ones in one system and interconnect them via a standard Ethernet cable, and have basically just one of these data manager cards used in such a system. So this is then possible with the snap inverters, and yeah, that's also one way to do it with the snap inverter series. So I'm at my last slide. So the last topic I want to mention is, why should you stick with Fronius? What's in it for you? Why does it make sense to use Fronius in such a PV-Genset solution? I have a few answers for you. First of all, I think it's worth to mention that we are still a family-owned business. We are working as family-owned business since 1945, and I think it says a lot also about the business itself, that we can keep it up running as family-owned business. It's definitely a good statement that we can keep up with this work. It's made in Austria. We try to push the limits when it comes to top-notch quality, and try to do so in the future as well. We have about 30 years of experience in the solar. So we started in different business units, but since 30 years we are working with solar and have a high quality service and support. You can reach us from all around the globe, basically, if you have any issues, any problems, and outstanding product design to withstand harshest conditions. Again, the link to the testings that we do to ensure the highest standards for the products, so that you don't have to run outside into the field every now and then to do a service. Okay, so that would be it for my part. And for the next part, I've already clicked once too many. I hand over to Christian and give him the moderating rights, or the mouse rights in this case. So Christian, let me know as soon as you got the possibility to move the mouse.
Yeah, please just go one back. Thank you very much, Christoph. Your presentation was very, very informative and explained quite a lot of what ELUM does and how we can integrate with your solution. My name is Christian. I'm the sales manager for Southern Africa for ELUM Energy. It's nice to meet everyone. So let's start with the first slide. ELUM is a monitoring and control solution provider. So we come in at the end. Fronius supplies the inverters, and we supply the control and the monitoring platform for these type of solutions, whether it's solar, diesel, or even batteries included into the system. At the moment, we have offices, or our main office is in Paris, and we have offices around the world in Casablanca. I'm in Cape Town. There's also offices in Sao Paulo, Mumbai, Dubai, Mexico, and Madrid. We have actually more than 1,000 sites already equipped with our controllers at the moment in more than 50 countries. It's a huge step for us into the market. And basically, we integrate with most of the big inverter suppliers like Fronius, as well as many others. Let's see. So for our first slide, we can look at decentralized and renewable energies, and we can see that it's already a scalable and profitable solution at this stage. I mean, there's lots of small solar plants or power plants that is coming up, and basically helping the grid and grid reliability, especially in South Africa and up in Africa. When we look at the energy monitoring and control we do, we provide solutions for standard projects as well as any type of hybrid project. For power plants or utility scale projects, as you can see here, microgrids, as well as the CNI space that we use, that you can use our controllers for. You can see here in the middle, on the left here is the controller we use, or one of the controllers we use for our PV-Genset control, as well as a few others that I will talk about later at a later stage. Basically, our solution is for the EPC market, or the EPC. It's made for easy installation, and also we provide a support team to help you with this installation. You'll see that it's also very cost effective in the way that it saves you fuel, as well as you're not losing any PV while the genset is running. So also relating to our controller, we provide high-end hardware integration, but the main focus is the reliable software on this controller that we provide our customers with. it's the main focus of the company. So if you have any kind of new inverter or something that's not yet integrated, we are happy to integrate it cost-free. It also helps us in the sense that the next customer with this specific inverter has the capability that it is already integrated for him. So that's it on this slide. Going back to the previous slide. Let's look at the integration for an on-grid system. You'll see here there's a few sources of energy, the grid, the gensets, as well as the PV. And we can see here how the ELUM controller integrates with the PV plant, gensets, and grid. You'll see the yellow or orange lines represent the data communication. So you have data communication between your PV plant and the controller. As Christoph mentioned, it's either Modbus TCP or RTU. Then you also have data communication between your gensets and our controller. This can be a power meter with CTs or current transformers, or it can be directly integrated with the already installed genset controller that you have. Let's say, for instance, a deep sea or smart gen or anything like that. We can integrate directly with it if it is Modbus TCP or RTU compatible. You have the same thing with the grid connection. There's a meter with CTs constantly measuring and seeing if the grid is available or not. We also have the controller connected to the internet, to our ePower Monitor platform. That's for the remote monitoring and control for the O&M teams. You always want to have a look at your plant and see if everything is running smoothly to make sure everything is fine. Then we get to the AC coupling. The grid, the gensets, and the PV is connected. In this instance, you'll see that the gensets is not running. I think the next slide will actually tell us that. Not there yet. Let's go to that quickly. How it works is we have two instances that are control, or that you can look at when you think about the control for your solution. You have the first part, or the first situation, where the grid is connected to the PV and the gensets are off. That means the gensets is not working, the PV is producing, and because of this meter on the grid side, you basically have the capability of zero export. On the right hand side, situation 2 is where you have the backup generators on, or in grid forming mode, and the PV needs to be curtailed to actually have the genset run on its genset minimum loading. Let's just go back to some challenges and opportunities that we face in this industry for solar diesel integration. I mean, a big thing is the reliability of the system, and to ensure that everything works as it should work, and finding a solution with the compatible equipment. And as I've mentioned, we can integrate any type of inverter. This is a Fronius and ELUM webinar, but I should mention that we are capable to integrate any inverter or different kinds of inverters into one system as well. Then to comply with the grid requirements is also sometimes a challenge. And I mean, Africa's unreliable grid, load shedding, it makes a huge impact when actually designing a system. Also, the underdeveloped power infrastructure in the African region is also a big thing to look at. You get a lot of off-grid sites just because of this underdeveloped power infrastructure. There's no power lines running to remote villages or every part of this of Africa. So you have lots of off-grid or small microgrid projects. And the last thing is most countries are experiencing the surge in fuel prices. I'm sure it's a very big motivator in that sense. When we look at the opportunities this creates, we look at solar hybrid systems combining PV and diesel gensets for a more cost-effective fuel-saving solution that we can offer our clients. We also look at gensets that offer the capability to always be able to fill the load while the power generated by the PV system actually provides a good, reliable source of energy. We also look at PV diesel hybrid systems, cutting the fuel, like I said, the fuel costs or the fuel consumption costs, as well as if you implement PV diesel systems, they actually provide a way towards a more sustainable future, less CO2 emissions. Let's see. Okay, we're getting to the grid feed-in management. Like I previously explained, this is just a bit more information to get a better picture of this grid feed-in management and how it works. You have your load and your PV running quite close to each other. So your PV is matching your load, and because of in some situations, the grid operator does not allow the feedback of the PV. You then have to curtail that PV and have grid zero or grid feeding management. This is what the PV does. It runs with the load to be able to actually not feed back to the grid. This blue line is the grid. Then we get to minimum genset loading. This is the second situation that I've talked about. So it's like it says here, it's during a blackout or load shedding, or I mean some situations where it's off grid. This is the constant. Once again, this blue line is the genset starting up, and you'll see that the solar in yellow just conforms to the extra bit of power needed on the load side of this particular project. It curtails the PV by quite a lot. So this is the PV production that started. Once the genset starts or the power goes off and the genset starts, the controller curtails this PV production or PV power to ensure that the genset runs on its minimum loading. Right. We have two solutions, our SD or solar diesel solutions, our SD Plus and our HFS solution, which is this one. They are mostly almost the same, not the same in hardware, but almost the same in software. The SD Plus is more for smaller sites, So you can integrate up to 300 kilowatts, or site up to 300 kilowatts with this SD controller, whereas the HFS controllers, there's a few options, the smaller and the bigger one, that can go up to 3 megawatts. In this case, both of them have genset minimum loading capability, so the controller automatically adjusts the solar inverters power according to the genset load, to use as much solar power as possible on your site. It also has the grid feed-in management, as I previously explained. That's the zero export, and data logging capabilities for these controllers, where once you connect them to the internet, the protocols they run on, or the main two protocols, is Modbus RTU and TCP, but also we can also run Sunspec, Solivia, Gecko, Blue Planet, PMU, and others can actually also be integrated upon request. The data export and visualization, we are able to not, if you don't want to use our monitoring platform, we are able to, with FTP push, port this data to a different site and give you access to everything from our controller. So we don't limit you to the fact that you have to use our controller, you have to use our monitoring platform. We are able to send that data out to help you. With the configuration interface, or the hardware side, we use a user-friendly configuration interface through a local web browser. So you plug your computer into this device or into this controller, and it's a user-friendly interface where you can go through the settings and set everything up. This will be with our commissioning support team. So you'd have remote assistance from a qualified ELUM engineer to support your team and in installing this device. The HFS, like I've mentioned, is almost the same. We add a metal casing for this controller, so it's already, everything is already pre-built for you. Getting to our references, or some of the references that I can just go through with you. There's a gas station in Morocco, and quite a few others as well. But this one has 10 kilowatts worth of PV for this Fronius SIMO. As Christoph has mentioned, you can also add quite a few SIMOs in parallel. And then we have a battery system of 15 kilowatts, as well as a 50 kVA genset. In this situation, we only did the logging, or the data logging. There's no actual control on this site. It was commissioned in 2019, and the system already functions. The client only wants to see more data on what's happening on his site in one platform, like monitoring the fuel consumption and things like that. For our next one, it's also a site in Morocco, a factory with, again, 10 kilowatts worth of PV, 5 kilowatt genset, and batteries of 20 kilowatt hours. As I've said before, we do any kind of hybrid system. So in this case, it's a grid-tied microgrid solution. It was commissioned in 2017. And on this site, we ensure the minimum genset loading, as well as maximize the solar PV penetration with the genset. The genset comes in just to charge the batteries in the case that the grid is off for longer periods of time. This was also, or the suppliers for this site is Clean Energy and the Fronius distributor in Morocco. Oh, sorry about that. The last, it's almost the end of the webinar. We'll go for questions afterwards, but the last reference we have is a PV plant of about 500 kilowatts in Peru, coupled with 4 250 kVA gensets, so multiple genset integration. And then in this case, because it is larger than the 300 kilowatt of the SD controller that we have, we're using the hybrid fuel saver in this case. As you can see here, it aims to ensure the genset minimum loading, and it monitors the equipment installed on site, like the solar inverters. It is also able to manage or monitor the fuel consumption and send an email to the installers or the maintenance team to fill up the generators when empty or close to empty. Right, that's the end. You can contact me directly on my email address if you have any queries or questions that you would like to still ask if it was not answered in this webinar. Also visit my LinkedIn page or the ELUM website directly to contact us. Thank you very much, Christoph, for this webinar. I think I'll give over to you. I think there's still a few questions that we need to look at and answer.
Yes, we have actually a few of them. I'm quickly changing the presentation mode so that the guys can see us now full screen, basically. Yeah, we got a lot of questions, and I thought maybe we can go through them, or at least a few of them together. And some of them are for Fronius, some of them are for ELUM, and some of them for both of us. Maybe I start off with one of the question targeted for you. So we have heard about the diesel backup solutions that you can also provide, so that the diesel generator just kicks in if there is a outage, a grid outage. Do you have also fixed solutions for a battery integration, or is this a special component you need to use for that, or is every product compatible with a battery? How does it look like there?
So because we are a software company, but we can implement any kind of design you would like, but we do have already built solutions for including batteries into your system. So we have the ES and ES Plus. So that stands for energy storage and energy storage plus. This is also small solutions. So up to 100 kilowatt hours worth of batteries, or up to 300 kilowatt hours worth of battery power. It's easier for smaller systems to have a already built custom solution, whereas the bigger projects need more looking into and more custom integration. So we don't usually have a system already built for that, but we do for the smaller systems.
All right, I see. Thank you. In the second part, I want to clarify one thing that was asked. I think I can answer it. Christian, you will just jump in if you can add something. The question was, okay, what happens now if you have too much PV power in a PV-Genset solution. And what happens is, already explained by Christian and me, that it will be curtailed. So that's the main feature of the controlling system or the controlling mechanism, to ensure that there is always a minimum genset loading. If we have grid and we are allowed to fit in, there it goes. There we have to surplus power. If you are not allowed to fit in, we have to regulate the system down. And this curtailing or this derating of the system is done by, or at least started by, the controlling mechanism. So ELUM tells the Fronius inverters, okay, we need to reduce the power by X%, something like this. Can we leave it like that, Christian? Yeah.
I think you explained it very well.
Okay, perfect. All right. There was one more question about the visualization, and I now want to target also the ELUM side of the visualization. And a specific question was around, is it possible in the visualization of ELUM to differ what amount of energy did come from the PV-Genset solution and the amount of energy we got from the grid? Is there any differentiation in the visualization tool you've got?
Yes, so the monitoring platform we have shows you exactly how much power the genset has provided for the system, as well as how much PV in that time was provided for the site. So it's perfectly aligned and split, so you can see exactly what you're looking at and plan ahead if you would like to.
Okay. All right, perfect. So I have one more question. That's a question for both of us, I guess. The question was regarding internet connection. Can I run a system off-grid as well? So offline, sorry, not off-grid, of course, off-grid. Can I run a system offline as well? So from Fronius' point of view, I can tell you it's not a problem. You can do it offline, but it is highly recommended to have the inverters online, because you have the visualization, you have the possibility to have a good and fast service if anything happens. So our tech support team can directly log into your system and help you if it's online, and you can do updates on the software remotely. So a few benefits would speak for the online bringing of the system, but it would work offline as well. Is it the same for you for ELUM controllers?
Christoph, it's mostly the same. I would also suggest or highly recommend having an internet connection. This is also because the commissioning is done through WhatsApp call and also with remote logging into this device. So you actually need an internet connection. We supply our controllers, or we can supply our controllers with memory cards that then store the memory or all the data collected on the site for extended periods of time. I mean, if you're only able to get the site online once or twice a year, it can send that data through to the monitoring platform. We also have the capability of installing a 3G or 4G SIM card to help with this controller to be online. There's also a great method to, especially up in Africa, where there isn't always internet available on the site. So that's a great option to look at.
All right. Okay, perfect. We got a few more questions, but I would leave it for the live Q&A part for now. I would just suggest that we both, or actually the rest of the team in the background, will focus on them and answer you in writing. So you will get the answers, of course. And also after this event, both of us teams will get the questions in a document, and we can work on it and then answer you via mail afterwards. So no worries, we will contact you and you will get the answer to your question. And yeah, the only last question, an organizational one, I want to bring up now is, what about the presentation? Of course, there will be a presentation document or a handout, you could call it, after this session. It will be sent out by you on a follow-up email, which will be sent out by ELUM in the upcoming days. So you will be able to, first of all, rewatch the session because it was recorded, and you can also take a look into the handout and a few more slides if you want to. Okay, so that's more or less the end now of the event, of the webinar. And yeah, last but not least, I want to say thank you. Thank you to ELUM, thank you to Christian, to Geraldine for the whole work around creating this event and managing it. And also a big thank you to you out there for joining today, the attendees. And I hope it was interesting for you. Hope to see you in other webinars soon. This wasn't the last the last event we did together with ELUM. There will be more in the future for sure. And yeah, hopefully I can welcome Christian as well in one of the upcoming events. We will see when we do that. Okay, last but not least, thank you.
Thank you.
Have a good day and we see each other soon. Bye-bye, guys.
Thank you. Bye-bye.